Hello. In this lecture, we're going to be looking at Chapter 7. We just finished a great deal of content on data communication, how we're communicating data across networks and all that good stuff. And now we're going to jump into intranets, intranets, and extranets. And some of our outcomes for this is we're going to take a look at the makeup of the internet, talk about how we navigate the internet, search engines. This is a lot of this stuff you're going to be familiar with. We're going to talk about internet services. We're going to talk about web applications, the purpose of intranets, the purpose of extranets. We're going to talk about some different trends. We're not going to spend a lot of time on trends in the lecture. You'll have an opportunity to look at that in the book. And then we're also going to talk about the Internet of Everything. And if you're not familiar with that, I think that's a very interesting part, a good concept of things that's happening in the world around us today. And I think we'll have some fun looking at that stuff. So let's begin with the internet. What is it? Well, in essence, it's a collection of millions of computers. And these different computers are all kind of interconnected with one another. And collectively, we call them the internet. Now, it is derived, meaning it comes from some projects by ARPA, the Advanced Research Project Agency, and it's called ARPANET. And this was built back in the 60s, the late 60s, 1969, by the Department of Defense. And they would use that to communicate different defense information across the United States. Eventually, it spread out of government, out of the Department of Defense, and became kind of the broad internet that we are used to. Now, the internet itself, although it's a collection of millions of computers, it does have a core grouping of machines that we consider the internet backbone. Okay. Now, these are a few machines, not a few, but a lot of machines that are linked together with very high speed network. We call it fiber optic. Some are computer, some are academic, some are commercial, but they're high volume machines, high capacity routers. And we talked about routers in the chapter that came before this. And a lot of them are private companies. Now, if we think about who makes up the internet backbone, it would be companies that you would suspect. Time Warner has a role in the internet backbone. Verizon, AT&T, these big communication companies, a lot of their cabling, their wiring, their infrastructure is what we use to serve the internet to the United States and the world. And even though when we say world, when we say World Wide Web, that's something, the www is so ubiquitous at this point. We don't really understand what's the difference between the internet and the World Wide Web. We know the internet is a collection of fiber optic cables, high bandwidth kind of medium. The World Wide Web is different. It is kind of the graphical interface to this hardware backbone. So, when did it come about? About 1989 is when we really saw it emerged. And that's when we added graphics to text. And that graphics have really changed everything. Imagine surfing the internet and just seeing green text on a black background. And then imagine, well, you don't have to imagine, compare that today where you see hypermedia, which is video, images, text, hypertext, which is text that has links, colors, bolding, italics, things that can really help you determine what's important and what's not important. And that's what the World Wide Web is. The internet itself is just kind of a platform to do things on. And the World Wide Web, if we could go back to the layer metaphor that we were using in the last chapter, is a layer on top of that that provides you with an opportunity to really make meaningful communications with that network. Now, to dig into how this works, we have to start with something called DNS, and that's the Domain Name System. Okay, this is another protocol. And what it does is it allows us to give names to those IP addresses that we looked at earlier. The IP is the Internet Protocol. We talked about that. And it gives us an address, which is a quad set of three-digit numbers. And we can translate some of those into names. And names, of course, are the things that we look at when when we go into a browser. We don't type in we don't type in 8.8.8.8. We type in google.com. So that's a name that resolves to an internet protocol address. Well, that name we typed in is actually called a resource locator, and not just resource locator, one that's uniform. So it's a URL, and that URL goes to a domain system, a domain name server or system. It translates that URL to that IP address and then connects it back. Okay. And then a TLD tells us the type of domain. It's a top level domain. So .com is for commercial. .org is for an organization. .edu is for education. Matter of fact, we can break this out in a pretty clear table. So right here we can see that we've got our domains right here. Well, I'm sorry, our top level domains right here. And then here's the type of group that typically works with it. And this is exactly what you would expect. Now in recent history, in the past, there used to be just a set number of these, 8 or 10, and there was a group of people, a consortium of very important minds who would decide what suffix could come after the domain name, .com, .net. Well, recently they have opened that up to where any and everyone who has enough resources can request a dot something. So I could make dot unsettled, or dot your last name, or dot farfanuging. So, these are things that are options. Now, they have to be approved, they have to be maintained, they are very costly, but we're expanding past this kind of group of 8 or 7 or 8 TLDs into a huge amount. So, there's some exciting things happening on that front. Now, these domains, when we resolve down to a domain, what we're looking at is what we talked about before, hypertext. But hypertext is made up with a language called HTML. The HT is hypertext markup language. Now, what this is, it's a language that uses tags, and these different tags break websites into sections. And then within those sections, you can apply different attributes. So we can change the font color. We can, work on different page components. We can make the page dynamic. Well, not dynamic, but we can make the page visually stimulating. And that's what HTML does. So let's put this into context. We have a domain name system. We give it a name. It takes us to an IP address. On that IP address, using the World Wide Web, we can use HTML to make kind of a graphical interface. So we're moving along. So we see how this sits on top. Let's talk about the different types of internet connections that we use to, consume HTML. We can start with, the 3 big ones out there are dial-up. We've talked about that in the past. Cable modems. I believe we talked about that. And a modem is modulate, demodulate, and then DSL. So if you should be comfortable with this by now. If you're not, take a look back at chapter 5, where we talk about network topologies, and I think we look at this a little bit. And then these internet connections allow us to use certain tools on the World Wide Web. And there are 2 big ones. There's 3 in total, but there's 2 real big ones. One is navigational tools. Now, this isn't something that says navigational tool on your screen. When you click a hyperlink, that lets you go from one website to another. That's a navigational tool. That's what we used to call surfing the net, where you would go to one website, click it, see how far the rabbit hole goes, click it, and go again. Opposed to that, you can also use search engines. I seriously doubt that we are having any confusion on what a search engine is. We're not going to cover that much. If you do need some more information, check the book on that. And then finally, we have directories. And directories are somewhat like search engines, except they are based on keywords and not really have a real good search interface. A search engine would use a directory to find this stuff. Google, which is a search engine that most everyone uses nowadays, indexes a lot of web pages, and that indexing is in essence building a directory, and then when you do a search, it searches through its index or its directory to find the page you're looking for. Okay, so to dig a little deeper into navigational tools, we've got web browsers. There are a lot of them out there. Internet Explorer, Mozilla, Chrome, Safari, Opera. Microsoft's introduced another one, Edge, with Windows 10. So we have a lot of those. And they have menu options, and a lot of the options are browsing history, bookmarking, viewing preferences, navigation buttons, ad blockers. You know, there are a lot of different features you can incorporate into a web browser nowadays. I would suggest that if you don't have an ad blocker, get an ad blocker, and that if you don't know how to adjust your browsing history or determine how to either keep or erase cookies and all that stuff within the browser, I'd say do a Google search. You know, and how would I search? Well, one option would be crawling the web. Well, this isn't how you would search, but the search engine could develop a search by crawling the web. So what does that mean? The folks at Google, if they want to add search capability to their search engine, well, what they can do is they can just go to one website, index it, go to all the links on that web page, index it, go to all the subsequent links and index it, index those. That's called crawling. Okay. Now what they've indexed, all this data is stored in a data farm or a server farm in some location, and that's where they keep these indexes that they use for when you're searching. So to go to from a user perspective, I go to Google, I type in a search term. I don't search the web, I search Google's index of directories. It gives me back a result. Then using a navigational tool, you know, a browser, I click that hyperlink and it takes me to that page. Okay. Some of the directories are crawler based. Some are human powered that actually have people going through looking for that type of stuff. And, you know, there's some interesting stuff about directories in the book. I do want you to dive a little deeper. I don't want to spend too much time on this, but I do want you to really take a look at those directories and understand it, because you may see it on the test. Now let's talk about internet services. Okay, services rely on the TCP portion of that protocol layer stack. Okay, and what we stack on top of the TCP are simple message, that's email, and then post office, that's email as well. And then some popular services, internet services, are emails, newsroom, discussion groups, relay chat, instant messaging, and internet telephony. And we're going to dive into each one of these. We're going to start off with email because that's something you're familiar with. We've emailed one another, most of us in this course. You receive email announcements from me every time we do something in Blackboard. So let's take a look at how email is built for your consumption. There's two types. There's web-based and client-based. Web-based is when you use your topper mail. That's a web-based client, a web-based email. Now, when I say when you use your topper mail, I mean when you are on a computer and you go to that Outlook topper address and on that website, typing your email address and credentials, that's web-based. If you are checking your email on your phone, that's client-based. Here's the difference. A web-based email is software on a server remotely you're interacting with through a browser. A client-based means that it is software on a physical device, whether it be a phone, computer, tablet, you name it. That's a client-based email service. Okay. Now, what do good email service providers give you with your email? Folders, so you can organize it, address books, and distribution groups, spell checkers. The best thing since sliced bread is spell checking, and then delivery notification. So that's what we can expect from email. One thing about email, though, one of its drawbacks is once you send an email, you cannot get it back. You cannot reclaim it. You cannot erase it from the recipient. So, you know, when we're talking about email, be careful with those reply buttons. Reply all, reply forward. if you use those incorrectly, you can create a great deal of misfortune for yourself. Okay. Now, that's email. Let's talk about news groups and discussion groups. News groups are something like Reddit. These are kind of forums where anyone can subscribe to it and get different news around any topic they like delivered to them, pushed at them, matter of fact. So, news groups are pretty interesting. They had their heyday. It was all about news groups in the 90s, in the early 2000s. They're still out there now, but they're not the same as getting news from the Wall Street Journal website. If that's not what a news group is. A news group is a special type of kind of news protocol where you get news from insiders in a specific field. It's very similar to a discussion group. The difference being a discussion group is where you create topics, you can post messages and people will reply to your messages, versus a news group, which is it's very similar to email, where people push out kind of a news item and then people respond to the entire group on that news item. Okay. That's different than instant messaging. Now, here it's talking about IRC, Internet Roulette. IRC was really big a while ago. It's very similar to IM. And when people think of IM, they might be thinking about Google, Windows Messenger, Yahoo. Most of these are for instant real-time communication. Okay. The Internet Relay one was all about exchanging text messages. Instant messaging is on that line nowadays. Where do we see this? What are the instant messengers that you're most likely using nowadays? Probably Facebook Messenger, probably Snapchat. Even, and Snapchat is kind of one of those amalgamations of different messaging technologies. It does have the text messaging, but it also has the pictures and whatnot. But instant messaging is just that. You hit it, you send it to a user who's also on that same instant messaging network, and they receive it instantly. And this can be real time. A lot of times email is not a real time platform. When you send an email, you typically do not expect a response from the email instantly. But with instant messaging, you can see that the other person's online. You send them a message, you expect a response very soon, if not instantly. And moving from text, sending instant text, is kind of instant voice, which is telephony. And, this is an evolution of the telephone, plain old telephone system. We call it POTS. And now we use the internet to provide voice over the internet protocol. So what do you need? You need a high-speed internet connection. With that, you can make international calls a lot cheaper. Sending something via data is cheaper than having its own special line going through the world. We can use it to route phone calls more efficiently than plain old telephone systems. And, now this says it lacks call quality. I'm not sure. The internet, voice over the internet has come pretty far nowadays. And a lot of times when you are making phone calls, if you call a professor at Western, you're talking to them over a VoIP, because Western uses that voice over data. So a lot of times you cannot tell the difference between this and traditional phone lines. So, what's the takeaway here? We're moving a lot of our Intranet, Extranet, a lot of the services that were not internet based are now becoming internet based. And voice is one of the ones that is, which is dragging behind in that sense, but it is catching up, and voice over IP is becoming very popular. Even if you think about services on the iPhone or the Android phones that are like line 2 or second line, where you can have another number. Magic Jack is a good example of this, where you can have a phone number when all you have is a internet connection. So that is voice over IP. Let's take a look at web applications. And web applications are applications that used to be on client machines. And I can tell you exactly what we're talking about. Think of Microsoft Office. That is an application you install on your physical computer. Well, there are web applications that do the same thing. Google Docs, for example, is one of those applications. Google Docs has spreadsheets, it has PowerPoints, it has Word documents, word processing. And by them delivering it via the internet, they can do it much cheaper and make it free or very inexpensive versus its competitor, which is very expensive. So when you think about these web applications, it's migrating systems that are expensive to download and install to web platforms that are very inexpensive. There are a lot of use cases for web applications. There's higher education use cases, healthcare, real estate, publishing, tourism, air travel, you name it. There is a web application use case for most of these industries. They are in the book. We're not going to cover them here. For real estate, there are a lot of options, but I imagine you've heard of Zillow.com. If you don't live on campus, you've probably had to use an online real estate tool. So I'm going to leave it to you to do that research because these different use cases are important. But I want to spend our time hitting kind of the big high-level concept things in this lecture. And then you can kind of pick up those things which are interesting, but not really difficult to understand on your own. Okay. So let's shift gears again and go to intranets. This is one of our big keywords here. What is an intranet? Well, it is a network that is inside of an organization. Okay. It's like a corporate portal. This is just internal information used by employees and people that are trusted within an organization. Okay. So why do you use an intranet? Well, part of the reasons you would use an intranet is to solve organizational problems. In our office, we need a way to communicate silently between staff members. So we use an internal instant messaging program. So that's a good use case of a intranet. Another one would be you have legally sensitive documents that you need to have your executive team to access, but you don't want the broader internet to have it. That's another, use case of an intranet. Now, an intranet's different from a LAN in that a LAN is a small network of connected computers, but an intranet requires authentication. It requires people to have well thought out access privileges. It defines and limits access. And that is a very big difference. With a LAN, a lot of times when you plug into just a local area network, you can access the entire network. In financial organizations, once you're on the internet, you cannot access the outside internet. So, here's a good example of what it looks like. On the intranet, we have all the people, the collaborators, the business partners, the managers. They connect with the internet to get to this back end of hosted stuff, enterprise applications, documents, e-business, and they may be able to get to the World Wide Web. This is not a guarantee for intranets. Okay. This type of stuff you can typically see, but here you may not have access. On campus, we do have access. We log into TopNet, and that's our intranet, and then we can find out these different things. And then we can also get to the internet from there. Now, what is the difference? Here are your takeaways, okay? An internet is for anybody. An intranet is for only approved somebodies. An internet is all over the globe. The intranet is actually physically in places controlled by the business. The internet is slow in comparison to an intranet. Well, why is that? Well, with the internet, you may be surfing the net in your bedroom or in your office, but the server you're communicating with may be in San Francisco, California. With an intranet, typically the machine you're working on is in a geographically close area. It might even be within the same building as the server you're interacting on. So since it does not have to span those great distances, it's going to be very fast. Security. The internet is a very insecure place. We've talked about this in several chapters. An intranet is going to be far more restricted. It's going to be that walled garden where everything in there you want is there, but there are a lot of walls keeping people out who don't need to be in there. So those are some of the key differences, some of the key takeaways. There are more, but those are the 4 that I'm going to expect you to know and understand. Okay. Now, some of the business applications of an intranet: human resources, sales and marketing, production, the money, accounting and finances, calendar management, documents, and then finally, it just reduces cost and time of document production. And that's one of the key things here. When we talk about this ROI for these systems, not having to print out multiple copies of a strategic plan for all 14,000 employees in a company that size, it's going to save a lot of money. Okay. So that's an intranet. Let's shift gears and go to an extranet. Okay. Now, an extranet is something that uses the internet and web technologies for intranet types of stuff, and it lets you communicate between organizations and consumers. And of course, we have some really good acronyms for here. We have an intranet, interorganizational system. That's iOS. If you're an Apple user, iOS probably means something different to you. But for this, it's an interorganizational system, which means one business can communicate with another business with this system. Okay. And, the thing that comes to mind is banking, money transactions. So, if we look at EFT, electronic funds transfer, who can, in your mind, see if you can think of a system that is kind of external to organizations that facilitates a transfer of funds. Give you a hint: if you eBay, you use this system a lot. PayPal. PayPal is a real good use case for this type of extranet because it is something external to companies that companies use to communicate certain tasks. And when it comes to funding, PayPal is a way to do that. Another one is electronic data interchange. We've talked about data interchanges before in the past. Those are examples of extranets, how you're sending data from one place to another. I know on campus we have a lot of systems that require student data. And the way to do that is you pull the student data down from the banner system, upload it into a secure, different system, and that allows you to, manipulate records appropriately. So why do you do this? Why don't you just keep an intranet? Why would you engage with an extranet? Well, it allows you to reduce cost. And again, a lot of this is about cost reduction. You can use a different company that can get an economy of scale doing what you want to do. And the other thing is it allows you to build out a comprehensive security system because you can control things that are deep down safe. Then there's kind of a different level of stuff that needs to be safe but isn't as critical as the stuff before it. And then the broad internet, which is pretty insecure. And let's look at a graph that illustrates that. Here we have the stuff we need to keep secure. This is our intranet stuff. Then here between the firewalls, they call this a demilitarized zone, the DMZ, we have this extranet. And this extranet helps us do some communication. We can use it to communicate with the internet, partners and suppliers. But our partners and suppliers, they're not going to get into our intranet stuff here. No. They're going to connect to this extranet. Then the extranet is going to communicate with the intranet. So this is layers of security. If we have a compromising situation on the extranet, we can keep that isolated from the intranet, but we can still use this information for these business partner supplier transactions through not through third party, but through an external extranet. Okay. So let's look at some of the advantages of that. It's easier to coordinate. There's feedback from all of our different stakeholders. We can achieve some consumer satisfaction because we can build it to meet the needs of the people on the outside, not just the inside. It's cheaper than reproducing an intranet for everybody, and it expedites communication. So let's recap a little bit about where we're at. We've talked about the internet, how it is built on a backbone of medium, actual physical wires, physical cords. On top of that internet, we can stack the World Wide Web. We can stack internet services like email, instant messaging, these communication things. After that, we can build a lot of web applications. So for hotels, restaurants, you name it, we can conduct business on the internet with this graphical interface, and we use a browser, a navigation tool to get there. Okay. So now we're going to talk about some different trends that are emerging on the internet and things that we should be aware of. Okay. So there's Web 2.0, and this is where web applications are very interactive and they behave like something you install on your computer. I'll tell you an example of probably the most heavily developed web application in the history of mankind. And it's something that's free and you use it and you don't even realize how well built it is. And it's Facebook. And I'll give you an example. If you've ever worked at a job where they have their own computer system, and it could be a huge company like Walmart, McDonald's, their computer system that they use looks pretty primitive. And that's because it focuses on security, not user interface. Well, Web 2.0 and Web 3.0 is all about interface. Okay. With that being the case, we interact with the most well-built user-friendly systems all the time, these Web 2.0 systems, and we don't realize that they are unique. Most of the websites you go to are not Facebook. They are HTML. They're hypermedia. They are not these highly collaborative web applications that are dynamic and perform. Okay. That said, there's a new evolution to that, which is Web 3.0. And what that means is that you take Web 2.0 and you make it more personal, make it where people can personalize it more, how you can work more intelligently. You make it predictive to where based on what you're doing now, it knows what to give you next, what to load up for you. And, helps you better interact with the computer that you're using. Okay. So let's do a little comparison. Web 1.0 to 2.0. Some things that make sense is we went from personal websites to blogging, which is, very interesting. From a business perspective, we went from kind of double clicking to AdSense, where the ads are served up based on the page. We went from content management systems. We still use these to a limited degree to kind of wikis, which are more interactive. And we went from, we went from posting a movie on our personal webpage to posting it on YouTube. So what will 3.0 look like? That's still being developed. You all, after this class, may take an interest in web development, and you may be the pioneers of Web 3.0. If Mark Zuckerberg could build Facebook, I think you guys could do it too if you're interested. So we'll see. Make something amazing. That way in 5 years, when I'm giving this lecture to a new group of students, I can reference you and talk about how you revolutionized the world with Web 3.0. Okay. So we're going to just quickly dive into a couple of those different Web 2.0 platforms. First, we're going to start with blogs. And a blog is just that. It's your way to communicate what you're interested in. It's short for web blog, web log. A log is your journal, your thoughts. Putting it on the web makes it a web log. And since everything on the internet is shortened, we just call it a blog. Okay. It reflects personality, philosophical thoughts, you name it. Now we also have a micro blogging platform, which is Twitter. Who knew? All this time you've been blogging. Okay. We're not going to talk about wikis. I want you to look it up. We're not going to talk about social networking because I'm pretty sure you've heard of it. If not, that's in the book as well. But I want to talk to you about something called a RSS, and this is a really simple syndication. Now, RSS is where you can deliver content on a schedule, where someone can subscribe to your content and then reliably they will receive, I don't know why I'm moving my hands to demonstrate this because you can't see it. They will receive updates and notifications when the content you've provided is available. We do this using XML, which is also a markup language. X stands for unknown, which means that you can create any format that you want. Unknown markup language. It's similar to HTML with tags, but it's not specific like HTML is. But where RSS feeds really shine is in podcasting. And this is where you create either an audio or a video file. You upload it on this schedule. You go to iTunes or iPodder. People subscribe and they can listen to it all they want. I'll tell you a podcast that I really like is Master of Memory podcast. And this is a podcast of a man, I think he does it every day. And he tells you memory techniques to how you can remember anything. I say that out loud because if you're a student like I was, I really could have benefited from knowing how to strategize memorizing things when I was in college, other than watching, I didn't really have a chance to watch the lecture, reading the book over and over again and taking feverish notes in class. Memorizing, having a memory strategy would have helped quite a bit. I would have saved hours. And that is an example of kind of a podcast that I listen to. Okay. So before we move on, let's talk about the internet, because the internet is getting crowded. So what do we need to do? Well, with anything, we need a 2.0, and that's what people are working on. The Internet 2.0. And this is a collaborative effort. People trying to create new ways to do the internet. So advanced internet technologies, digitizing libraries, teleimmersion, which is teaching in different ways, creating local connection points where people can have high performance networks in where they live. Google did this when a couple years back, they asked the United States which city wanted Google the baddest, and Topeka, Kansas said that they wanted Google to come and put high speed in their city, and they renamed Topeka Google, Kansas for a little while, and Google installed high speed fiber. So, here we have 50.0. That's what I pay for, and we feel like it's okay. In Topeka, they have 500.0, and it's provided free. And that's what they want to replicate in different parts of the world, and definitely in the United States. Before we close, let's talk about the Internet of Everything. And this is where we put different technologies in things around us and get them on the internet. Now, we use RFIDs, we use wireless systems, QR codes, barcodes. This is how we interface with these things. But the Internet of Things is actually putting physical objects around us on the internet. So let's talk about somewhere you would see that in your day-to-day life, and that would be that Nest, the Nest thermostat. That's a good example of an Internet of Things. So it's something physical that used to be, not smart, that now is smart, and is connected to the internet. There are other things. Inventory systems do this. Programmable appliances like stoves, fridges, roads and bridges do this as well. I went to a programming conference a couple years back, and there were some entrepreneurs there, and they built libraries for programmers to be able to turn on any and everything via wireless internet. And this is where we're headed. The Internet 2.0 is not just changing the way we view web browsers, but also changing how we interact with the physical environment we're in. How do we control the light bulbs? How do we control the vacuum? That type of stuff. So what we looked at today, we looked at the differences between an internet, an intranet, and extranet. We looked at where we think the future of the internet's going to be. We looked at some of the critical things we have to be concerned with when we're deciding how to deliver service to business partners. What should be safe? What should be not? What do we not have to worry about safety with as much? Okay. We will have a content quiz this Thursday, and we are going to have an assignment to make up points for the content quiz that we did not have this past week of fall break. And the assignment we're going to have is going to involve the Internet of everything, the Internet of things. Okay, so do the reading. Make sure you understand these key concepts. And welcome back from fall break. Let's get to it.